I know that, okay, on my 20th December, my temperature was around 19 degrees Celsius. On 21st, it was around, let's say, 20 degrees Celsius. On 22nd, it was again 90 degrees Celsius. Now I want to know the temperature at my 23rd date, right? So this 23rd, my area of interest or my variable of interest that I want, this will become y, right? This will become y. And all the previous days data, all the previous days temperature data, these will become your x. So this will be your y t minus 1, right? Let's first of all take it as yt. This will be your yt minus 1. This will be your yt minus 2. And this will be your yt minus 3. And let's say here will come my yt. So what my auto regression says that my yt will have a relationship with my previous y values. This c is my constant, and now w1 will be my weight associated with my t minus 1 value of y. w2 will be my weight associated with my t minus 2, and w3 will be my weight associated with my t minus 3. So in auto regression, we are just taking the regression of term with itself, as the name is also suggesting, auto plus regression, taking the regression of the term itself, right? And here, now one question comes into picture that, okay, till how many previous time steps, previous data points I have to take, right? For example, here I am taking the last 3 data points here, right? Last 3 time steps data point. That's why it is yt minus 3, right? Now, that particular thing that will decide the order of your AR, order of AR. And that is generally represented by my P. So this P term will tell me that, okay, till how many previous time steps I have to take my data points. So in this particular in this particular case, my P is equal to 3 because I am taking past 3 data points, yt minus 1, yt minus 2, yt minus 3. I'm talking about the temperature data, but again, the same thing will be applied to your IoT sensors data also, or your stock price data also, and whatever the thing that you want to apply also will be applied on your NLP problems, natural language processing problem. If you have a one particular step, one particular sentence itself, that is, again, I'm writing that my sentence is I am going to, and let's say this is my blank space. Now for predicting this particular thing, this will be my yt here, right? This will be my yt, and by what auto regression says that this particular thing will be dependent on my last terms, right? Obviously, if I have mentioned somewhat about that, okay, I'm 12 years old and it is the morning itself, and if I'm writing a sentence that, okay, I'm going to, it will automatically predict that, okay, maybe school will come, because 12-year-old guys in the morning generally goes to school itself. So time series and NLP data are kind of related in this particular way itself. So auto regression, we talked about. So AR term standing for auto regression, just taking the regression of term itself in my previous time steps data. Next comes MA, moving average. So here an average is in the picture, right? So what my moving average says that my value of y at a particular time step t will be equal to my mean of the complete data. For example, again, taking this particular temperature data itself. So it will say that, okay, will be equal to mean plus C1 phi t minus 1 plus C2 phi yt minus 2, and so on. And what does exactly these particular terms represent, that I will be telling in a moment. And at last, one more term will be added, that will be my phi yt. So this mu is my mean of the data. So here, if you see for this particular data set itself, my mean will be around 19 plus 19 plus 20 divided by 3. So it will be around, let's say, 19.4. I'm assuming that it is 19.4. I'm not sure. not calculated, but let's assume that a mean for this particular data is 19.4. So what does it say, represent? How you can calculate a moving average is that your temperature for the 23rd December Y23 will be equal to this 19.4, your average from the previous days, plus C1. Now comes this psi phi t minus 1. So this psi yt minus 1 is nothing but the difference of your mean with the previous date data, right? So in this particular case, my mean is 19.4 and my yt minus 1, which is this 22nd December, is 19. So my this psi yt minus 1 is basically equal to 0.4 itself, right? Just give me a second. Just like yeah. So this psi yt minus 1 will be 0.4 itself, right? So here 0.4 will come. Now C2 and this psi yt minus 2. This again will be calculated in the same way. 19.4 minus yt minus 2. In my t minus 2, it is 20. So minus 0.6 will come. In this way, you will be able to calculate these psi values, and you have new values. Now, in the learning process, your iteration process of the learning, say, simply as we train a simple linear regression, right, by using least squared error, by using gradient descent. In a similar way, these C1, C2 values will be calculated, right? So this will be this was your moving average in your ARIMA model. Now comes integration, I. What does this I stands for? So what generally happens, again, one assumption for your ARIMA models is that your data, that we are talking about, need to be stationary in condition. Need to be stationary in condition. So stationary basically means your mean is constant and your standard deviation is also constant at all data points, right? Now, if your data is not stationary in that particular scenario, your ARIMA models cannot help you, or you will not be able to use these ARIMA models. So for making them stationary, sometimes this particular thing known as differencing comes into picture. Differencing comes into picture. So what exactly this differencing is, for example, again, I'm taking that I have some data, let's represent it by Y. I have some data, again, if I take the, let's say, pressure data from a sensor. Pressure data I have, again, for different type steps. My P1, P2, P3. And I know this particular Y is not stationary. After performing some of the statistical tests, I know that my Y is not stationary. So what I'm going to do, I'm a data scientist, so I have to do some experimentation. So first thing, what I can do, I can make it stationary. I will try to see that if I take the difference of two consecutive terms, that if I take P2 minus P1, and then I take P3 minus P2, the similar way I go on below my data points. I will take this first differentiation, and again, that is known as your differencing the data, and let's represent it by Y dash. I have made this particular data, and I will see that, okay, if this particular data Y dash is stationary or not. And there are chances, there are high chances that your Y dash maybe sometimes comes stationary, but again, not surety, surety is not there. There can be chances that your Y dash is also not stationary. But yeah, if your Y dash is stationary, then you can directly use this auto regression and MA on that Y dash itself. You can use directly this auto regression and MA on that Y dash itself. And then this I term will come into picture because we have taken a difference of 1. We have done first order differentiation, right? First order differentiation. Now to get back to the original values, get back to the original scale of this y, I have to integrate it again, right? So basically, I have to take the previous value itself, or you can also say the integration factor. So from there, this integration or this items comes into picture. Just reverse the differencing that you have done, and again, this differencing will again depend on different orders. Maybe there can be a chance that your y dash is not stationary. In that particular thing, you need to take y double dash, where what you will be doing, you will again taking the y2 dash and taking its difference with y1 dash. So these are your ARIMA models, basic statistical models. Now, the problem with these models are these are not able to kind of get a non-linear complex relationship between your yt and your yt minus 1s, right? And for solving that purpose, for solving that particular purpose, your neural network comes into picture. Again, if we again, if we take the analogy of this time series analysis itself with the simple models, AIML models, you know that there are statistical models or shallow learning models present for simple data, random forest, and all those things. But there is a scenario that for if we have some complex relationship between my y and x, we need to use neural networks because those are way better in handling the complex relationships of your feature and target variable, right? Now our neural networks comes into picture. AR takes into consideration autocorrelation. Karim K is answering. Yeah, is asking the question. Yeah, AR kind of stands autoregression. I think your doubt is solved. Right? Now, yeah, neural network comes into picture, or not simple neural network. The neural network that deals with the sequential data. Time series is a sequential type of data, right? Sequence. Yeah. RNN comes into picture. RNN or LSTMs. RNN, you can just say that RNN is the father of LSTM, came before LSTM, but it has some particular issues. That's why LSTM came into picture. And currently now, nowadays, we generally use transformers and all those things. But main concept behind them is same. Now here again, as I mentioned, when we are encountering some high frequency data in our industry, production industry itself, if we have some sensors data related to some equipment, they will be a higher frequency data, right? In those type of scenarios, your RIMA is not able to deal with that particular thing. So for solving all these problems, your RNN came into picture. Now, first question, how RNN is different from ANN? So as I told you, as we started this session itself, that your ANN will deal with the simple data, right? And RNN will deal with the sequential data, right? So how RNN will deal with the sequential data? So RNN is kind of having a sense of memory. In a similar way, human beings have a sense of memory. RNN also have a sense of memory. Using that particular sense of memory, it will remember that, okay, something has happened several time steps before. And when we talk about the ANN, in ANN, time this time dimension is not even present there. We are just talking about point to point, you can say point to point operations. So time dimension is not even present there. So in RNN, there is this sense of memory that will help to get to previous data, right? And give you an output. And again, we will see in mathematical terms also how all these particular things work. So this is your basic structure of RNN. Here, if you see, I am passing my input inside my RNN, and it will perform some operations, some mathematical operations, right? I don't know what mathematical operation it is performing at the moment, but yeah, it will perform some mathematical operations on my input data. And after that, it will give me an output Y. And what it will do, it will also feed this particular encoded data to itself again. Now, if you unfold this particular RNN here, let's assume that I have designed a neural network that will take last three time steps of data, xt minus 1, xt, and xt plus 1, right? And here one RNN layer is present. So what exactly is happening in RNN is, first of all, this xt minus 1 will be encoded, or your feature will be extracted from this xt minus 1, and it will be converted to some other state known as hidden state of your neural network, represented by this ht minus 1, right? Now this is your encoded data. Encoded data that is useful for your LSTM for learning the feature, right? And now by using this encoded data, again, mapping, because neural network at last will be doing the mapping between y and x, right? Y and x, it is trying to find the function between them, right? So we will get this yt minus 1 from this xt minus 1. But also this hidden state of my t minus 1 data point will be passed to next time step also, right? So when I am trying to, or my neuron, when this neuron is trying to get a relationship between my xt and yt, it will also know this ht minus 1 from my previous step. So it will also know some of the relationship that is encoded inside this ht minus 1, that is storing the information of the previous time step itself. So it will get to know that, okay, something is happening in my past, and that may be or may not be useful for predicting my future. So in this way, your simple basic RNN models will perform, right? Now, but the main problem with these RNNs, simple RNNs model was that there was some loss of information there. If we go deep, or if we go back a lot in the past, it was not able to remember the stuffs. You can say it is having short memory issues. It doesn't have long memories, right? So for solving that particular scenario, my LSTM came into picture, right? And how LSTM works, or what is the what is the inner structure of LSTM, let's say. So for solving that particular long-term dependencies of RNN, LSTM came into picture. And here, if you see in LSTM, there was this hidden state, right? So apart from this hidden state, one more thing was added inside my LSTM, that was this cell state. So this is a basic, or you can say this is a basic structure of one of your LSTM cell, how it looks like, right? So I will be explaining one of all of these units itself that constitutes your complete LSTM itself, right? So there are three different things, three different parts make up your LSTM cell. One is your cell state, one is your hidden state, and the third one are your different gates, right? So cell state, you can say that cell state is nothing but the complete memory of your LSTM cell, or you complete a LSTM network. You can say that it is the memory of your LSTM network. It is the thing that is storing the information of the complete data, right? Or it is in an encoded way, not exactly, right? So cell state, you can say it is concerned with my complete data. So all information will be stored inside this cell state. Again, in encoded way, encoded data, right? Not exactly. And how this cell state will be calculated, that again will be seeing. And this particular cell state is affected by your different gates, your input gates and forget gates. Because as we go on adding more and more data, we need to decide what data we need to remember from my past and what data we need to forget. That particular thing is your forget gate. And if we add new data for the next time steps, again we need to take a decision how much of that particular data I need to remember and how much to forget. So for now, just remember that your cell state is kind of associated with your complete data itself. It is storing the complete data in form of your some uh, encoding structure, right? Complete data is stored in encoded structure. And the other one is your hidden state. Your hidden state is kind of more concerned with the previous time step only, right? So if I'm talking about let's say T, let's say I'm talking about T, right? So this hidden state will be storing the information from my previous cell itself or previous time state itself. So it will be having the information of complete T minus 1. In one way, these cell state and hidden state are kind of interrelated with each other. Again, when we will be seeing the mathematical things going on behind, you will be able to get an intuition of how these are interconnected with each other. But for now, just remember, hidden state is for your previous time step only, more concerned with the recent time step, right? Just the time step that has happened recently. And again, this hidden state is not equal to the output of one particular cell. Again, it is the encodation of your recent time step data, right? So hidden state, I'm writing here, recent time step and cell state from all previous time steps, all previous time steps. So what exactly happens here? Again, let me make LSTM cells here. You are saying that you are giving three inputs. For determining your YT plus 1, we are giving it my YT, let's say YT only. Well, I'm giving my YT minus 1. I'm giving it YT minus 2. I'm giving YT minus 1. And I'm giving my YT. And I'm trying to map. There is a complete, let's say, architecture of my neural network having LSTM cells between it that is trying to get the function. What function? My YT plus 1 is equal to function of my YT minus 1 and YT minus 2. And let's say this YT minus 2, minus 1 and YT, these are combined, are directly connected to your LSTM cell. So these are my LSTM cells. So these will be interconnected with each other also, so that your previous time step data will be passed on to next time step data. Now, when we kind of remove this cover of your LSTM cell, inside your LSTM cell look like this. So there is this horizontal straight line running out of your LSTM cell. Just assume it is a conveyor belt, some of the conveyor belt going through your complete LSTM cells that are connected together. Here, let's assume this is for my YT1 because it is getting the input data at time step T itself, right? Previous one, the cell before it was for T minus 2. So this conveyor belt or your cell state is coming from that T minus 1 itself, not T minus 2, it's T minus 1. And before T minus 1 was T minus 2, right? So this cell state will have information of your data from previous, both the data points T minus 2 and T minus 1. And the hidden state that is coming below will have your data from T minus 1 itself. Now, this horizontal line is your cell state. Again, a conveyor belt type of structure having complete information. This particular green box is your forget gate. It will decide that what information that I'm getting from my cell state for my previous cells I need to remember and what information I need to forget. How it will do, we will see. So this is your forget gate dealing with historical data or previous time step data, what to remember and what to forget. That will be handled by your forget gate. Next, this blue box is your input gate. Now this input gate will decide that from the current input, the input that I'm getting for my time step T, how much I need to remember and how much I need to forget. And again, all this remembrance and forgetness, all this particular data will be stored inside your cell state itself after some of your mathematical operation. So this is your input gate deciding on your input And last is your output gate. So output gate is responsible for giving the hidden state to the next time step. So here my next time step it is showing yt plus 1. So giving the hidden state to next time step, right? So now let's get into the gates itself in detail. So first one is my LSTM gates. First one is my forget gate, right? As I said, it will decide that total what amount of data, instead of data, let's say encoded data that I'm getting in form of my CT minus 1, my previous cell state. From that particular data, how much I need to remember and how much I need to forget. That particular thing will be decided by this particular forget gate. And how it will decide, here you see that this hidden state from my previous cell is coming, and my this current features for current time step t is coming. And now this particular operation is concatenation. So I'm concatenating these ht minus 1 and xt together. And here a matrix will be formed here. And that particular thing, your simple neural network operations, multiplying that particular thing with your weights. This is your weight, WF, wait for forget layer, right? Then add the bias in that particular term. Again, bias for your forget layer, right? Now this complete operation will be passed through a sigmoid activation function. Why sigmoid activation function? Because it will give me output in term of my 0 and 1, right? So if my output of this particular forget gate that is represented by ft is 0 for, let's say, a certain given data point inside my ct minus 1, so it will directly say that, okay, that particular data inside my cell state is not important to remember. That is not performing any, you can say, good thing in my learning rate of my neural network. So that is not important for me to remember. So I just need to drop that particular thing. So it basically means that depending on my current state inputs, xt, depending on my current state input, xt and st minus 1, obviously, I am deciding that which of my previous data is important to remember, or we can just forget that particular thing. And depending on the output of this particular thing, 0 and 1, I will be remembering that particular data only. And here, if you see, is multiplication. So once I get this ft from here, from my input gate, it will be multiplied with my ct minus 1 previous cell state, whatever was my cell state. And here, it will be my ft multiplied by ct minus 1. Now, this particular ft into ct minus 1 is only having the information that is relevant to remember depending on my current input, current time step. Right? Ashwin is asking code to implement the same LSTM, but the operation I want is using fuzzy. Okay. Now this is your forget gate. Basically deciding what information from the previous cell I need to remember, previous time step I need to remember, and what to forget. Now coming to my next gate, that is input gate. So my history or past I have handled. Now come to the present, right? Now this will decide here in the input gate. If you see, there are two things. One is your sigmoid function and other is your tanh function. By default, this complete thing is known as input gate, but there are different notation also, where this particular sigmoid function, this particular thing is only known as your input gate, and this tanh thing is known as your candidate. This tanh is known as your candidate gate. But again, depending on whatever nomenclature you want to go. But for now, let's assume that this complete thing is my input gate. Now here, what will happen? Here, if you see, same type of sigmoid thing is happening here, IT. That is my output from here sigmoid. Again, my previous hidden state will be taken and my xt current time step input will be taken. Again, simple neural network operation I will perform. Then I will pass it from a sigmoid layer. Now again, this sigmoid layer will tell me that depending on my previous hidden state and my current input of xt, whatever the things I want to remember from the current state itself, and whatever the things I want to not to take in account. So it is hidden, it is input gate, right? We are inputting, we are giving some information to it. So this input gate will filter out the information that that will help it to kind of get a good function between your yt plus 1 and your previous day's data, and it will reject all the information that is not helpful for it, right? That's why this sigmoid layer came into picture. Now you know that, okay, this sigmoid, you decided that what to take input and what to take output. Now what is the role of this 10h then? Right? So this sigmoid just told you that, okay, this particular thing you need to take input and this particular thing you need to take as output. But you have to pass that information to yourself, right? So that information will be passed by performing the 10h activation on again, this particular equation. Here, your weights and biases again will be different. So what exactly this 10h or this particular 10h cell here is doing? It is doing two things. First, it is extracting my future. It is doing my future extraction from current input. Let's say from xt. So it has extracted some of the features that are important to learn, or you can just say extracted the future from your inputs itself and encoded that particular thing so that your neural network or your machine can understand. So this 10h is handling that particular thing. It is extracting features from all the inputs and encoding them. And this IT or this IT, this complete thing is your CT, that is your feature extracted and encoded for your this particular part. And this IT, it will make the decision that from these extracted feature, which one to take and which one to forget, right? And again, if you see at this particular point-wise operation, multiplication is happening. Obviously, multiplication will happen, IT into CT. So these are your extracted feature, and these are your, you can say, your decision of sigmoid layer, which one to take, in which input to take, and which one to reject. In this way, your input gate will work, right? And if you see the particular output here, now coming back to your cell state itself, right? Now it's the time to update the old cell state into the new cell state. So from the previous cell, I got my cell state CT minus 1. Here from the forget gate, I got some information which information from the previous cell state to take and which one to reject. So I multiplied this CT minus 1 with my FT, CT minus 1. And now from this input gate, I got the information for the new inputs or for the inputs for the current time step T, and I will be adding those information in my previous cell state. So here it will come FT into CT minus 1 plus IT into C dash D, where C dash D is your output from this candidate layer and IT is from output from this sigmoid of your input layer. So if you see, your new cell state will be equal to FT CT minus 1 plus IT into C dash D. So your new cell state is having the information, some of the information from previous cell state, or you can say information, or you can say data encoded from previous time steps, right? From previous time steps. This particular thing is representing that, or you can say this is representing the time dimension inside your learning of LSTM, right? So we have information from our previous time steps itself, and in that particular thing, we are adding the information from my current time step, having this candidature CT dash multiplied by IT. So now this cell state has been updated updated to the information having previous state information as well as current time step information, right? So these are the you can say updation of your cell state. Now, from this particular LSTM cell itself, we have to give some output also. This cell state is directly going here. If you see, this cell state is directly going to the next cell. And let's assume that it is connected to the next time step, that is my yt plus 1. I'm also, let's assume that I'm also considering this yt plus 1 in the relationship for getting some y value, right? So again, in that yt plus 1, same operations will happen. That information for that t plus 1 cell step will be stored in the similar way as it has done for this particular time step t. Now your cell state is sorted. Now how to handle your hidden state, the hidden state that I was getting from my previous cell, right? And in the beginning, as I said, your hidden state and cell state are kind of interrelated with each other only. So for that particular thing, your output gate comes into picture, giving the output to your next cell, your next time step. So basically, this output is nothing but your cell state, but in a filtered version itself. Right, in cell state, the cell state was having the complete information of previous data points, and I said that your hidden state will have more information about the current cell itself, right? So again, similar type of thing will happen here. If you see, this cell state is coming here, this is going one cell state, and this is the same branch from that cell state itself. Now this cell state will be passed, the cell state will be passed through 10, this particular 10H, and one other this hidden state from previous layer and XT from previous layer will be taken, and output from that particular sigmoid cell will be this OT. And now this again OT will decide how much of your this current cell state you want to take inside your HT, current hidden state, right? So this OT, again, if I tell this, that is this OT is again considering the information, how much to remember, how much to forget. So this particular thing is that, and this HT here, not HT, this complete HT, the hidden state will be calculated by multiplying this OT with the 10H of my current cell state. And this particular thing will give me my hidden state. So you can see your hidden state is kind of related with your cell state itself. Again, depending on how much to remember from the current cell state and how much to forget, and taking this 10H. So basically, if we saw in and saw the complete LSTM in high level, when we are talking about sigmoid, when we are either amplifying the things or diminishing the things. When my sigmoid layer output is nearer to 0, I am diminishing that particular thing. And whenever it is nearer to 1, I am amplifying or I am completely using it. And your 10H is basically used for for making the normalized encoded of your data, normalized encoding of your data, right? So in this way, we are able to calculate the hidden state of this particular cell, and all these things again will go on. Are we going to see a Python implementation code? Yes, Pramit, we are going to see that. But yeah, this is the intuition behind your LSTM cell. In this way, your again, and all other things, whatever the things takes place for the training of simple AN, and all the things go on in the same manner itself. There will be your gradient descent. There will be your different epochs, your forward pass and backward pass. All things will be there. But if you remember, in ANN, we just learned one W and C for one cell. And here, if you see your LSTM cell, your one W and B is present for your output gate itself, one W and B is present for your input gate, one W and B is present for your this forget gate, one W and B is present for your this IT here, and one W and B for this CD. So multiple W and Bs are there. Basically, 4 W and Bs will be there. If you see here, we show you one W and B for this sigmoid thing, one for this one for this 10H1, and one for this sigmoid one. So your ANN, we are just learning one set of W and C, but for your LSTM, we are learning 4 sets of W and C. That's why these are computationally heavy also for training an LSTM cell as compared to ANN. I hope the intuition behind the LSTMs are clear. Now let's jump on to our coding part. If you have any doubts, you can ask in the chat box. Yeah, I will be sharing the presentation as well as I will also sharing the code, and you can also find the complete code and presentation on my GitHub profile also. At the last, I will also share that. But yeah, let's start with the coding itself. And give me a second before going on to coding. Let me tell you one more thing. How exactly the data will be prepared for passing it inside your LSTM network, so that it will be easy for you guys to understand. Okay, let's assume that let's assume I am having some machine data, some machine equipment data, right? And it consists of data from several sensors data, right? And my problem statement is to determine that whether anomaly or whether my machine broke down or not. So my problem statement is anomaly detection, right? So I am just taking that I am having X1, X2, and X3. These three sensor data points, let it be pressure, temperature, or whatever, right? These three features are present. My target value or target variable is Y. That is whether anomaly is present or not. So it will be 0, 1, 0, 1. Right? 0 representing normal condition, 1 representing my anomaly condition. Right? Now, I know I am having this data from IoT sensors. These are time series data. Right? So basically, this anomaly, that whether anomaly is there or not, it will depend on the previous data points itself, previous behaviors of my these sensors data itself, right? And now let's assume that I am having how much? Let's say 1,000 rows of data, right? For my X and Y's. Now, how will I feed these X and Y's inside my LSTM architecture, right? Basically, if you know, your AI/ML model is nothing. You input X here, and you also input Y here, and you will get a FX file. FX, right? Basically, a function that is mapping your Y with respect to your X. Now, how to and whenever we are talking about simple ANNs, your artificial neural networks, we just give inputs of your X1, X2, and X3, and there is some, let's say, neural network here, and it is directly mapped to your Y. In this way, we generally give inputs, but the same thing is not true for your LSTMs. So in LSTMs, first of all, you have to make the batch depending on one particular time window, right? Now, this time window, you can decide by your domain knowledge. For example, here I'm talking about machine data, I'm talking about a compressor data. So now if I am having a great mechanical engineer with me, he will definitely tell me that, okay, your compressor data or your breakdown of your compressor is kind of dependent on your last 100 time steps data. Or let's say I'm getting these data per second. So he will tell me that, okay, if whether there is anomaly or not for a given machine or data in a given machine, it is dependent on your last 100 time steps or last 100 seconds. So what I will do here, I will take my first 100 data points starting from my X1. Here, this is my X1, X2, and X3, these features, right? I will take my first 100 data. This is my X1, 1, X2, 1, X3. The similar way, this is my first time step data, and this is my 100th time step data. That is my X100. You can say X100, X200, and X300. I will take this complete batch of data, and I will try to map this particular data with my Y101, right? So I am just telling that I am operating my machine for 100 time steps, and my Y101, my machine condition at 101th second is dependent on these previous 100 time steps data, right? On these previous 100 time steps data. So in this way, if my neural network is finding some of the different nature of these data points for these 100 steps, it will automatically tell me that, okay, for 101th day, you will face an anomaly. Now I have to feed my this particular style of data, right? I have to feed the data inside my LSTM cells in this particular style itself. So how I will do it, right? X1, X2, X3. I have total. I have 1,000 days. Let's assume 1,000 days of data for simplicity for now, right? And I said that my 101th day condition, is dependent on first 100 days, right? In a similar way, my 102nd day condition will be dependent on last 100 days again, 2 to 101. My 103rd day Y will be dependent on last 100 days again, right? So I have to make my batches in this way. So what I will do, this is thousands, right? So I will take X1, X2, X3. I will take first 100 days data. I will make a one batch of it, right? And this particular thing I will map with my Y101. Now my next batch of data, this particular thing, will start from second day and go till 101 day, right? In a similar way, my next batch will start from 3 and will go on this 102. This one will be mapped with Y101. This one will be mapped with Y102, and this one will be mapped with Y103. And this way, this complete X and Y will be passed through my LSTM architecture. And it will be able to get the relationship of my Y 100 plus T with my previous underlying step, right? Now let's jump onto the coding and see how to create this particular data things, right? And for this particular hands-on coding, first of all, I am taking the example of univariate time series forecasting, and I'm taking as I'm a petroleum engineer from my bachelor's or from my education point of view, education background. I'm taking account. I'm taking the project of crude oil price forecasting, right? And in a similar way, you can also forecast some of the shares value also, but for practice purposes only. If you are going to make decision depending on these particular LSTM models, then if you go into loss, don't come to me. Just for practicing LSTM, you can kind of pick up this type of things. But again, how we exactly are not able to do these things, again, the limitation part we will discuss in the end of this. So first of all, I'm importing all the libraries that I am going to use. I'm importing my pandas, numpy, and for plotting, matplotlib, right? These are imported, and for getting the data of my crude oil price, I'm using this particular website where my Brent crude price data is updated every day. So I will be using that particular data, and I'm just using my read.html function of my pandas, right? So this is my data frame. If you see it here, and as I have used read.html, my complete data will be stored inside a list. So first of all, let's get this particular thing in the data frame itself. So by indexing the first element, I got my data frame. So here you can say, see, this is my Europe Brent crude. Basically, there are different types of crude. Again, we will not go in deep, but yeah, this is the data points for my Brent crude. Here, it's mentioning Brent crude. This is my basically time step. It is representing that, okay, the data is for 19th December 2022. Frequency is my days per day data has been taken account, and what was the value or what was the price of my Brent crude of 1 barrel of oil on that particular day. So it was around $81. But let's let's get rid of these crap things that I don't use, that I don't want. I just want this value thing, and I just want my date, right? So first of all, I'm getting these things out of my data frame, period and value. So this is my final data frame. First of all, let's convert this period into date time format again also. So I'm using my pandas function to date time for converting this period into date time format. Right now, if you see here, my period has been converted to date time here, 19/12/2022, and I'm having the data from 20th May 1987, right? A lot of data is there. I'm going to use, right? This period is not necessary now because I have time information from this date column itself. So I'm going to drop it, setting the index as date. These are some of the basic points. So I'm not going into detail, right? Just preparing my data frame itself. So my data frame here, I just reverse the data. So I just want the past data first. So I just reverse the data itself. Nothing else. Now, first of all, let's plot. So this is my time series. That is looking like it, right? Now let's just get the value of crude only. So I'm storing this particular series inside this variable df1 here, my crude values only. Now we will be scaling the data because our neural networks are very sensitive to scales, right? So I'm using a standard scaler here for scaling my particular data. Just using sklearn for scaling the data. And after that, just storing that particular thing again. So this is my scaled version of the data. Yeah, Gunter, I will be sharing the notebook. I will be sharing the link of my GitHub also where you will get the notebook directly. And also the analytics Vidya guys will also share it or share it to you on there. But for now, just focus on the class itself. Right? And now if I see the scale data, this one is my scale data. You can see on my y-axis, my scale has reduced to -1 to 3, right? And here, this was the original data. So I just scaled using my standard scaler only, nothing fancy. Right now, I am taking the window size that I discussed here, that this particular window size, this time step size here for my machine data, it was 100 time steps, right? Given by your, again, domain expert. That particular thing I'm giving as input here. So here again, I'm giving, let's say 100 days data. I'm just mentioning that my 101st day of crude price is dependent on the last 100 days of crude price. Okay, I've given. Given the input 100. Now I'm just splitting my data into training set and test set. And as you guys know, we are talking about time series data. So there will be sequential split. By default, if you use train test split from sklearn, that randomly splits your data. That is not valid for your time series data. So you have to sequentially split your data point or complete data itself. So that particular thing I'm just doing it here. So this is my shape of my training data and testing data. Having one feature, that is my price itself. That is feature and that is target value also. Now this will be my complete training data. Do you have a good mathematical explanation paper how LSTM works? Yeah, I will share you the original paper of LSTM itself, the original research paper when they came up with the LSTM and how they moved on from RNN to LSTM. Right now, this particular function, that is my create data set function, that is taking care of the creation of my batches depending on my window size. So if you see the logic here written in my for loop, what I am doing exactly here is I'm taking some my time step. That will be my W window that I have already mentioned 100, right? So I'm just taking my data X and data Y. In my data X, I will be filling up first 100 days of data, and in my data Y, I will be filling the 101th day of data, right? So this particular thing that we saw here, making the batches, this particular thing, first 100 days with 101 day, next 100 days with 102nd days, that particular thing done here by using just a simple for loop itself. And you can also do this particular thing by using time series generator that is present inside your TensorFlow library itself. But I prefer to do things by my own. That's why I have written this function itself, right? So this function will make the 3D data for me, for 3D batches of data that I need to uh, feed to my LSTM, right? So I'm just using this function here, making my training set and testing set. Now, if you see, shape of my train and test has been changed. Now these 100 are there. Why these 100 are there? Because I am telling that first day data is dependent on last 100 days data, right? So I've just done that particular thing only, nothing else. And as in my LSTM, 3D LSTM will require 3D type of structure, so I'm just reshaping it and adding one new dimension here of 1. This last dimension, if you see this shape again, what does this particular shape signifies? So these are the training and test training shape that we generally feed our neural network. So this last element represent how many total number of features are present. In our scenario, as I said, it is a univariate problem, so only one feature is present, that is our crude price itself. But again, if we talk about that machine example, that compressor example, in that particular scenario, 3 features will be there, right? This particular thing is representing what window size I am giving. What window? Ashwin, why reshaping is done? The reshaping is basically done because currently I have only one feature, right? But generally LSTM expects an input in a 3D structure. So if I have more than one feature, let's say if I have 3 structure, then I need not to reshape the data itself. It will automatically at this time step itself, at this particular time itself, it will automatically had given me a 3D array here. But as only one, I have only one dimension, right? One variable. So I need to get or I need to shape my array in that particular form itself, so that LSTM understands that okay, I'm getting a 3D structure, because LSTM only takes 3D type of data, 3D arrays only, it will take 3D tensors or whatever you want to give. And but when this one will be present here, it will understand that okay, this is a univariate type of situation. The last dimension kind of tells me total how many features are present inside my training cycle. The middle one dimension tells me how what is the time window that I'm taking. 100 days mapping with my 100 on day, right? And this particular thing is just calculated by this 100 thing only. For example, if I go above, here you can see my training data, my total training data was 8784, right? 8784 of those were there for my crude price, right? But when I made that particular data in form of this 3D structure, it has been reduced by 100. Why it has reduced? Let me tell you again. So if you, let's not take 5,000. Let's take 500. Let's say this is my variable y or x, whatever. I'm having 500 values here. Y 500 starting from my y1. And I said I'm making 100 days of window, right? So what exactly I'm doing, I'm taking first 100 values, y1 till y100, and I am making a batch of it. Now my next batch will start from my y2 till y100. Right? And this way it will go on. My last batch will end at y401 and y500. Now, if you see, and if you use some of your mathematical logic, how many total number of batches will I have? Number of batches will I have? So I will have total 400 batches, right? If you see, starting from y1 and going till y400, right? So I will have total 400 batches. And in a simple way, if you just calculate that initially I have total 500 lines of data, I am making 100 days of time window, just subtract it, subtract this particular thing, and you will get total number of batches. That will be 400. So this first dimension here is representing your total number of batches, 3D batches that we have. So that will be your 8684. That is your initial training data minus 100. Right. I hope this is clear to all. So this 3D batches has been generated. Now let's just call TensorFlow. And from TensorFlow, I'm calling LSTM cells also. Let's make an architecture of my model, neural network model, by using these LSTM and dense cells. I'm using sequential API of TensorFlow for making the neural network. So it is currently looking like this. Input shape, I have mentioned 100 cross 1. Why? 1, because I have only one variable. Price 100, because my Windows was set as at 100. So 100 cross 1 will be my input shape. Using my loss function as mean squared error, optimizer is Adam. And let's go train our model. I'm just using one epoch because it will take a lot of time for training. Let's just train it for one epoch here. Okay. Yeah. Model is trained. Now let's predict our X train and X test. Let's run the predictions and see how good our model is trained in one epoch. Obviously, it will give me very bad results. But yeah, let's check it. So I'm using inverse transform because my output from this prediction will come in the scaled version, right? Because we have scaled the complete data. So by using inverse transform, let's get back to you. Let's get them back to the original shape. And let's see what is my mean squared error. So my mean squared error for my training part is 56. For testing part is 99. Yeah, it is bad, but not that bad compared to my compared to the condition that I only trained for one input, right? So this was my training set shape. This was my testing shape. Let's make a complete data frame out of it, right? Of my predictions. And first 100 points will be NaN values in this particular data point. You know, because for first 100 points we have taken and then we have predicted only 101 point. So there is no way of getting the prediction for my first 100 points. That's why there will be NaN values. And that particular thing, I'm just doing it here in this form. Right? So this particular data frame I have just made by using simple pandas logic and Python logic. Nothing else I have done. Where it will be having the original values and predicted price. And as I said, first 100 values will be NaN because there is no way of getting the predictions for first 100 values. Right? And here, just using matplotlib for plotting purposes, for visualizing how would my model is trained. So the blue one is my original value, red one is my predicted training price, and green one is my validating price or testing price. So till this point, testing we have done. Now comes the question how to forecast in future. That okay, testing I have done, I had the data till 19/12/2022, and I just have done the testing. But how to predict in future, how to predict 20 days in future, 30 days in future, right? So let's see. Here, again, let me open my whiteboard and use the logic, but exact logic. There are two ways, right? I'll tell you the way that currently I am using. So let's again say I have data from Y1 to Y100, right? And I have trained in such a way that my window size is 100. Now this complete data will give me Y101, Y101. This is my model prediction. So now my first day prediction I got. First day prediction I got. Now for predicting for 102nd day, I will take these 100 days starting from Y2 going on to this Y100. I will take this 99 days of previous data and I will take the 100 point this that was predicted by my model itself. And I will combine this 100 days data and will predict my Y100, 102. In this way, I will go on predicting my future. But what is here, the thing that come into picture, that there obviously there will be some difference between my Y actual 101 and my this Y predicted 101. And there will be some difference. There will be some error. I predicted 101. And this error will go on propagation as we go more in future. So this is the drawback.
So sorry for the interruption, but we are running short on time. So I just wanted to remind you that.
Yeah, just give me 2 minutes. So now logic is clear. The same logic I've just implemented here. I have taken the last 100 points, right? And from those 100 points, I've taken these are my last 100 points in 10. And from these 100 points, the complete description I have written here, what I have actually have done, I am predicting for my next 30 days. So I have just written one if and else loop. My first loop will be this else loop. This else loop will run and will predict my 130 data. And after getting the 101 day data, that 101 day data and previous 99 days data will be taken inside my if loop and it will predict for my 102 days. In this way, I will be able to predict for my 30 days. Let's run this cell, get the output. So this is my output here. Now again, I'm just using simple pandas. And here, if I show you my prediction for the future, this is my forecasted value. This is my this is my testing value. You can see here that it is kind of getting some of the trend that okay, your oil price will increase in future. Right, so this was the implementation, and sorry guys, we had some of the time constraint. That's why I was not able to give you complete code walkthrough. But yeah, let me share the GitHub link with you guys. So this is my GitHub repository. Here you can find different projects, and let me share the repository. This is my GitHub profile where you can find different projects, and let me share the repository where I'm going to update this particular project itself. Yeah, I'm just sending this guys. So this particular one is where you will get this particular project. And this one is my LinkedIn profile. And also apart from this, I also run a YouTube channel where again I discuss this machine learning and deep learning subjects itself. Let me share with everyone, right? So this is my YouTube channel where I generally share all the things related to machine learning, deep learning, and statistics, mathematics, and physics also. Right? You can also subscribe if you want to learn more things.
Okay.
And yes, if you guys have any doubt, you can reach out to me.
Okay then, so I would like to wrap up the session now. Thanks a lot, Jayesh. On behalf of Analytics Vidya, I would like to thank you for your time and for delivering such a wonderful session. I'm sure our audience found it insightful, and hopefully we can conduct more such sessions with you in the future. All the links have been provided in the chat box, so you guys can see that. And also, the feedback poll has been launched, so I would request all of you to kindly fill before you leave the meeting. Thanks a lot, Jayesh, once again, and thank you all for attending today's session. Have a great day.
Thank you guys. Have a great day. Happy learning. Bye bye.
Thank you.